Hi, welcome to another video. Today's video will be learning how to operate a mud pump inside PLC program. It's just a basic program what we're going to write today. So we will be programming potentiometer and operating the induction motor from the potentiometer. Today's video will be using this small simulator for throttle, or you can say potentiometer. This is a 4 to 20 milliamps or plus or minus 12 watt signal generator, which we use to simulate the analog signals. Okay. The connection for this device is here. You have one side positive volt and 0 volt, then you have analog output current and voltage. Here you can use for current or voltage. Now we need to wire up this. We need to connect positive and negative to the PLC. We can use this 24 volt output from PLC to signal generator supply. So generally your potentiometers are 3 wire. You need one positive, negative and output signal from the potentiometer. So these are 3 wire device. The third wire will be connecting to analog input modules. So positive and negative will be connecting to a power supply, and the signal part will be connecting to an analog input module. Our case, this is a signal generator working with 24 volt, but we have output only plus or minus 12 volt. We need here in this simulation only 10 volt, 0 to 10 volt. Okay, positive and negative connected. Now we will be connecting the third wire to analog input channel 0. Okay, the connection part is finished. Now we'll go back to the program. Remaining all connection as our early video, VFD, joystick and everything we kept there as it is. Now we just adding one potentiometer, then we'll be start programming. Okay, let's come to the program. This is our old program we saw already in the previous video. Now we need to add extra programs here. So okay, this VFD, this is our frequency right to the VFD. This is what we using here to simulate our mud pump functionality. So the same motor we using, so same signal will be also using for output side to the VFD. Only the input we need to take from analog input, that is IW64. That's the first channel. Then your minimum you can put 0, or we can or 27500 is our maximum. Then the output, okay, let's wait, we'll make one data block. Then we can add all the data there, so it will be much more clean. So here we need to put our normax min max, normax out, scale x min max, and the output of calibrated value. That's we call pot. This means potentiometer. So we are simulating a potentiometer to operate the motor. So we'll be naming that as pot. Okay, let's go and start putting that data block value here in the Normax. Data block 1, then minimum, maximum, then the output to Normax output, then we need to add one scale X. These are 2-point calibration setup for the throttle. Minimum, put. Okay, so the block is this program is ready now. We can just download only. No, yes, no, not software. All we need to go back to software, just only changes we need to update. Okay, no, here is one problem, because our analog input we replace with this Normax value. Here should be IW64. Because we instead of we writing their Normax max, we put that Normax max into analog input value. Okay, this is IW, that's our input. Update the program again. Okay, go online. Now we have our min max. Okay, there we need to look in the potentiometer 0 to 10 volt. I think is 0 to 27,500 as reading. Let's move back to 0. Our potentiometer, you can see that is moving the analog input value. Okay, so that's 0. 0 is 0. Then here it should be, let's move to the maximum 10 volts and we'll see how much it's coming. Okay, that's 10 volts is 27,500. You will see a little bigger number there, but we need to put 27,500. Then the output is ready now. We need to put in the scale X value. The 0 should be 0 and this should be 60 hertz. Oh sorry, it should be 100. Then okay, now we have 0 to 100% our throttle. So 0 volt is 0 and 10 volt is 100 volt 100%. Now we need to make the writing command to the VFD. And so this reference we will be using to adjust the frequency in VF in the VF to the VFD. So you need to add one more block, and or we need to add one scale block, because we take this VFD frequency per data block value, then we will be simulating that with 0 to 6000. The 6000 is for 60 hertz. Then our potentiometer we need to put to input value. Okay, now load the program. So now we have potentiometer 0 to 100 percentage, and the output to the VFD is 0 to 6000. Let's simulate now and see. Okay, that is 3575. Okay, you can adjust the potentiometer and see. Okay, it's changing, the number is changing. Okay, now we need to write. Now the frequency signal is to VFD, but we need to write the command or enable the command for forward direction. Before we had in the program for forward direction, but that is with the joystick. Now we will take that value, then we use so we use this joystick forward parameter to VFD. Then we will be adding in our program with one new network. So let's add one new network and one switch and move block, right move. Okay, then paste here. Oh, just my mistake. 1 second. Let's no, it's correct. Okay, paste here. Then the input, we need to take that number, the number for forward direction, that's 18. Okay, then put that number here. Now we need to give one memory bit here to start by ourselves for rotating the motor. So in a real scenario this will be like on off switch or something, but in our case we need to put a switch with memory bit. Okay, just define tag, define. Okay, so program just download. Now we should be good to operate the motor from hand throttle or your potentiometer. So now we can adjust the frequency of the motor with this potentiometer. Let's turn on here this bit. Okay, the function will start moving. Okay, now it's start moving. Okay, it's just change and see. It looks like something strange here. Seems to be something strange. I think this number is too big on the output. We need to recalibrate properly. Scale X min max. I think we should put here 60 for 60 hertz. Let's put 60 and upload the program again, download the program again. Load. Okay, now it's okay. So now we can move back and forth and see how many. Okay, 0 frequency, then going up. We need to see how much frequencies. Okay, let's test now. We should be good. Let's start rotating the motor. Okay, you can see now we are controlling the motor with the potentiometer or the signal generator. You can see you can bring to 0 to stop. It's typical a mod pump function, just straight rotation. Then you can increase to increase the RPM. As you move up, your frequency output will increase and you get your speed going up in the inverter. Now we can go a little more. You can see when we increase the speed, so the percentage you can see in the input to scale side is like linear to the voltage from the signal generators. Okay, 0. So you can test. So simple. This is very simple programming because we had already the old program there, so small upgrade we required here to make this function happen. This is how we controlling VFD with or your motor with potentiometer. Okay, program is completed.